So I just kind of want to go through an analysis and see what's going on with Floyd 2 and Floyd 3. Where we left off yesterday, I have Floyd 3 configured with a workload to run now. I've got a batch interface. One of the things we finished up yesterday when we loaded PBS was we now have PBS accounting data, and we also have PCP archive data, SAR archive data, and CSA accounting data is configured on for Floyd 3 as well. So I've got the system close to instrumented. There may be a couple other things. For example, I might want to put Gangly on the system today, and that'll give me a baseline. One of the hard things here is looking at lots of data. So if I've got a month's worth of PCP data or SAR data or CSA data, it's kind of hard to pull that data apart and get a big picture on it. I have a tool called SPV. So Gus, have you seen SPV before?
Yes, I have.
So I've got that was working last night on Floyd 3 when I tried it. And so I had SAR data, PCP data, and PBS data that I could plot and visualize. So just like a real-world environment, we put the systems together the past 2 days, got workloads up and running. We now have the ability to keep the systems busy, though PBS itself might not be configured to allow enough work to keep everything on the Floyds busy. So we might actually be into tuning the queue structure or tuning the scheduler for the batch interface and making sure that we're not swapping, but that CPUs are busy. I need to reiterate here, though, just because a CPU is busy or a resource is busy doesn't mean it's productive, useful work. We can thrash. In my terminology, thrashing is when we're wasting 10% of the resource. It's always been like system time. If that's above 10%, we want to know what's going on. So in my mind, a 10-to-1 or 10% ratio is the threshold above which you're saying, okay, this non-productive resource consumption should be looked at now. So I want to log into Floyd 3. And I'm basically, just like in the real world, saying, okay, let's put the system up for users, make it user available, and see what they can do, see if they can tie up the system and stuff. Let me increase my font here a little bit, too. So in my analysis, a system info gather would give me most of the information that I need. It doesn't give me things like config-v. It doesn't give me the HWCFG type stuff. It doesn't give me SMN configuration. Okay. So I'm just going to sanity check myself, topology. 4 blades, 64 CPUs, about 256 gig of memory, 64 gig per node. LS SCSI. So there's my disk farm. I've got 2 base I/O disks, and then I've got a RAID with 2 paths to it. Notice they have the same LUN numbers over here, 2 different ports, 2 different controllers to the same device. I've not brought up SNE GUI to see how those LUNs are put together yet. That's kind of part of the advanced sysadmin class to see how those are put together. An XVM, show-T-E on vol/asterisk does shows that they are 4 LUNs put together into a single file system, and they're striped 2 wide and then concatenated. Now, the reason I did this was just for demonstration purposes, but by striping 2 wide, if I need to grow the system, I only need to grow it in LUNs that are 2 wide. I only need 2 LUNs at a time. Whenever you're growing a file system, you want to be symmetrical. If I had striped this 64 wide and I wanted to grow it, I'd need 64. I want to be symmetrical in file system growth. Also, what I was doing here was getting a little bit of striping by going too wide in my stripe, but not over-striping. And by doing this, I'm kind of tuning it more for lots of little IOPS rather than large sequential. I'm kind of dropping the stripe width down and then getting me more stripe units. These stripe units are decoupled from each other. So when I'm doing I/O, it's going to go across the two LUNs, and things like allocation groups, we'll talk about a little bit later, rotated eventually to the other stripe group because they're concatenated together. So just a quick inventory here, DF, showing me that that XVM right here is mounted as /scratch. Okay, and then I also had an NFS home and two partitions that are on the base I/O, the second drive on the base I/O, and then a partition. When Chippewa ships, they have a partition at the end of the root drive for a data one, and you got to know how to use that, or remount it as like /temp or something like that. Any questions?
Yep.
By the way, you see anything wrong? Okay.
Dev Shemem looks like.
Yeah.
No. Yes,
put that aside for now. Dev Shemem looks full. So during my inventory process, I might catch things. Okay. So I'm just going to start off with a SAR, 1-5. And this resource looks pretty healthy. My user time, nothing really running, nothing under nice. There's a utility called locate. There's a RPM that gets loaded, and at 4 in the morning, it'll fire off a find command and sort it and dump it into a database. That is an example of a cron event that runs under nice. File system defraggers, things of that sort. A little bit of system time, not much. Again, I'm not going to worry about it when it's less than 1%. Now, you got to be a little careful here when we're looking at a large system, because I could have a 4096 CPU system, and I could have, a CPU set within there, maybe 16 CPUs that are locked in system time, and I don't see it here. So the summary kind of doesn't help you as much as these systems get bigger and bigger. You really need to have something like PMG sys. I can't survive without PMG sys on these big systems anymore. So just because you may have low system or low IO8 doesn't mean you don't have problems out there. No IO8 being indicated here. Yesterday when we finished up, we were in a out of memory. I was pushing it to an out of memory event yesterday, and we started seeing the swap as an IO8. I'll get back into IO8 later, but with a WCHAN event, let me just do a PS-L here. There's a WCHAN event in here, and there's certain WCHAN events that get counted as IO8. I'll come back to those later. And IO8 does not include inode, directory, or metadata. It's only for the block device IO8, data IO8. So we had a memory intensive, a metadata intensive work running the other day, and high load levels, but we didn't see any IO8 time to it, and we didn't see any CPU time to it, because it was all inode wait and journal wait type of activity. I'm going to bring that back later in the class. So IO8 is indicating a block device IO8 situation. Basically, there is a IO_sched routine in the kernel that's being counted there. Deal is for virtualization, for guest operating system, VMware type of thing, and I'm not running that here. Now, if I'm running a guest operating system, any work that it does, any CPU time it takes, comes from system time. So guest will show up under system time until the CPUs go busy. Once there is no more idle time, then the guest gets counted as a steal, not as a system time. So we don't count the guest as a steal until it truly is taking cycles from a busy master host type of operating system. So if I have any idle time, some of my system time could be the guest. Anyway, everything looks healthy there, mostly idle. So now I'm going to do a SAR-R, 1 space 5, and check that one for my memory. And things look pretty healthy here, actually. 57% of my memory is being used. I don't know it on a per node basis yet. So I could still have per node problems where particular nodes are full. We'll take a look at that as we go along. So what do we got here? 86 gig free, 178 gig being used. But again, in my analysis, I want to know if that 178 gig is productive or not and what it is. 67% of the memory is used. Now, again, this was raw I.O., so we've only got about a gig of raw I.O. going on here right now, and that's not bad. Again, raw I.O. is any I.O. that went through /dev, make swap, a make FS, file system defraggers, XFSDB, make swap. Those are the kind of things that actually will result in raw I.O. Then we have our cached I.O., and again, I broke that out yesterday. By the way, I did make a mistake yesterday. Cache clean. I thought, you know, when you wake up middle of the night and say, doggone it, I did that wrong. When I defined cache clean yesterday, I defined it wrong. Let me do an explanation on cached right now. Oops. So, the cached field. In top and free, etc., is /proc/mem info cached plus slab. The slab is the kernel heap where all my metadata is. Then we have a cache clean that is PCP only. That was added quite a while ago. And that I defined wrong yesterday. It wasn't used. It's the cached field minus the dirty plus the write back. So dirty data is data that has been written by the application from user's memory to the kernel page cache, but it is incoherent. It is not flushed to disk. The flush daemon or a sync command will flush it, but we cannot recover that memory. That is not clean cache. And then write back is data that has been marked to flush. And again, I mentioned that I should also subtract the NFS unstable. I've got an RFE for that, but nobody is paying attention to it. So basically, dirty write-back NFS unstable is not memory that I can recover. Cache clean is what I can trim and throw away easily. The mistake I made yesterday was I was defining a term that PCP calls other. Okay? And that one was the used minus the dirty plus write back. And other, this is really the kernel and user space. Oops. Let me do something here. The free command. We're basically describing, as I said yesterday, the free command, but I wasn't thinking and just got it backwards here. So in a free situation, Notice the plus and minus sign over here on free. This is a really bad tool these days because this was a 2.4 kernel when they did not break out on pages, dirty, write back, all that other stuff. The minus sign says we take used and subtract the buffers and cache, and PCP is calling that other. And with free, basically they're taking the cached, taking free and adding the cache to it, saying that that is available or recoverable. But in fact, a lot of that cache data is not recoverable. Any questions right now? Are you okay? So again, in that cached field in meminfo, that includes the cache field just in meminfo is the dirty, is the write back. I can type right. And then the NFS unstable. So when I write, it goes dirty. When I'm writing to a disk drive or writing to a file, by default it's going to go through the cache and become dirty. Then either a sync command, a Fortran flush, or the flush daemon will wake up and say, we've got too much dirty data, or it's been dirty too long, let's flush it. And then that gets marked as a write back. So write back data is data that is in the process of flushing. Again, if you see write back data, that means your file system is not keeping up with the dirty. And if I'm writing to an NFS server, it goes from write back to NFS unstable. But I could have a ton of write back data that is trying to get to NFS. And again, these three assets can take up to 40 by default, or maximum of 50% of my memory can go dirty. After that, then, once it flushes, it becomes cache clean. Cache clean means it's coherent, easy to trim, PCP derived. By the way, PCP has the ability of having its own derived metrics now. That's something that I should mention here. Try to demo it a little bit later. So I can create a derived file in my .pcp directory and take two metrics and add them or subtract them out. Okay, also in the meminfo then, so that's my page cache, so to speak. We also then have shared text. Which is my executable. That's my program running, and my DSOs. Now, this is the problem that I think people don't really connect here. When you get into a memory shortage situation, first the slab will get trimmed, and that can be slow in trimming a large slab if it's huge. Then we go to the cache and try to trim everything that is inactive there. Then we try to trim the active. Then we do swapping. And there are sysctl parameters that control this behavior that are discussed in the advanced sysadmin class. So when I'm in a swapping situation, my cache has been pushed down to nothing. And in the cache is shared text. Also, if I do a BC free or drop caches, everything in the cache gets thrown away that's clean or shared text. Now, my bash shell is no longer in memory. So I try to hit a carriage return, no shell to respond to the carriage return, take a page fault for it, and have to go out to the file system, usually root and /bin, to get that executable. And that device is probably busy tied up with swap I/O at that point. And now you're in trouble. But you can get in the same scenario where you're truly not doing swap I/O, but the memory pressure is so bad on the system that you can't hold your shared text in memory. Does that make sense? After a BC free, you can usually see the disk activity, read that stuff back in. I don't like running BC frees periodically because of the impact that that has on cached data that is being reused over and over. Any questions? Now, what else is in this cache field? Temp, FS, memory, resident, file system. And one of those memory resident files is /dev/shemem. That is part of the cached field. If I do a BC free or drop caches, the dev shemem cannot be trimmed or thrown away. It, however, can swap. So if I get into a memory pressure situation, I might start swapping out shared memory segments, and they might be unattached shared memory segments that haven't been used in a month, and that would be non-productive. Also in here then was the IPCS, the shemctl system call interface for it. And fortunately these days, for both of these, there is now a shemem metric in meminfo. If I get into a memory shortage situation, I can check to see if dev shemem is part of my problem, that there are unattached files sitting out there. However, shemem not in the KDV summary command. I've got a request for that one. Let me get out of here. Any questions on that? So we're into memory. And again, I do my analysis. CPU, memory disk, file system, buffer cache. And that's kind of what I'm getting into here is the file system, buffer cache. Okay. So let's just see where we are here. SAR 1-5. I always like to see if the system is in the same situation. Oh, I see some IO8 this time that I did not see before. Let's see if that can be caught here. I'm just going to bring up a top. Oh, I see it. I'm going to do an F here. I'm going to do a Y to get the W-chan. Right here. Get request is one of the W-chan events that will get counted as IO8 time. So we got IO going on here. XFS above D going to SDB1. I'm going to do an I here. So the only thing running here is this is for journaling activity. And AIL is something called an action item list. This is where the journal has flushed to disk, but the metadata itself has not flushed to disk yet. That's what an AIL is. So my system is changing a little bit from what we saw before because I see a little bit of system time, I see a little bit of IO8 time. Two processes running. Let me quit out of there. LS and top are being caught. So let me go back here now. SAR-R 1-5, check my memory. Memory is about the same situation, and where I broke off was this one, cached field. So 137 gig of my memory is a cached value, but there could be a lot of different things in that cached field. BC free may not recover it. That cache field includes dirty, write back, and if it's unstable, might include the slab, it might include the shemem type of stuff. Any questions? The other metric in SAR-R I consider meaningless. This is what I have reserved versus what I physically have. So again, if I take a look at my proc mem info, we can over-reserve memory. Mallocs are always successful. What we're looking at are these two statistics here. This is the amount of virtual memory that I have. The amount of virtual memory is physical memory plus physical swap. And then this one is what I have reserved through a malloc, what I've committed to, but not what I've allocated, not necessarily what I've allocated. This is what I've reserved. But we can over-reserve memory. what we used to call virtual swap is on. And this is the same way Windows runs. Sometimes Windows will come up and say, you're running out of memory here, you're hitting this out-of-memory killer, you should increase your swap size, which is basically giving you more virtual memory. So let's just go back to SAR-R 1-5. So because we can overcommit, that KB commit is kind of a meaningless number. Okay, I'm still looking at memory, but I'm going to do a SAR-big S 1-5 for, oh, got a little bit of a problem here. My swap is 100% full. What I got a 10 gig swap, and it is all used. However, a lot of it is not in the cache anymore. Swap CAD. This basically is saying what percentage of the stuff that's out on swap is still in cache. It exists in both places. This can reduce swap ins. So if I run into a memory shortage situation, we squeeze and trim. Then at some point we start swapping stuff out, but we don't throw away what's in memory. That way, if I need to get to it again, it's still cached in memory and not out on the swap device. It exists in both places. So anyways, I do have a swap problem going on. I'm going to do a SAR-big W 1-5 and see if I have any swap IO, however. And I don't have any swap IO. In fact, let me do a SAR-big W from the beginning of the day. Oops. Oh, that's not good. My log is wrong for the date or something. Wonder if cron has a problem. Something's going on here. Let's see if I can. Oh, it didn't get killed. Well, something's going on such that the SAR, maybe because I made a change, but there's no SA12 file there. Let's do a check config on boot.systat. That is on. Let me try a service boot.systat start. Let's see if we got any file. Actually, there'd still be a cron event to fire it up. So we do have the Linux restart file at least there. Don't know what happened there. I was starting to think we had out-of-memory killer situations, that it might have been killed from that. Let's see. It ended last time we see it running was about 8 o'clock last night. So we don't have historical data from that SAR-W to see if there was any swapping going on overnight. There is PCP data possibly as well, I wonder. PM Logger has crashed too in the system. That out-of-memory event that we had seems to have impacted us. That's the only thing I can think right now. Nothing visible there either. Huh. Service, PCP, restart. And it is running now. Now there is a cron event that should, something's going on with cron here or something. We should have been able to catch that in ITC cron.d. So there is that systat, oh no, I'm sorry, the PCP one. And that should be running such that PM Logger check would make sure that PM Logger is always running. So that doesn't seem to be working right. I wonder, grep. Well, we didn't see anything in. log messages. There they are up until 2041 again. Something happened last night about 2041. Let's see. Just check this clocks here. I wonder, CSA com, like more. My data starts yesterday at 1400, so I do have CSA accounting data from 2 o'clock yesterday on. I don't want to do anything with that yet. What else? It was about 2041. Oh, 24. No, that's not the right one. It was slash space 20:41. Okay, I see an out-of-memory killer event here. 2041, there was an event that occurred. You cannot always trust var log messages. I do have PVs such that there may be things that are not in var log messages. In fact, it looks like syslog crashed at that time too. Huh. So that event was rather severe. Let's do something else. Demessage type. I don't see anything there either. Let's see what we got. 4 kills. Oh, I should have done a -I though. There's all the kills. Now do we have one that is? Still not seeing any event on it. Maybe it did try to grow on its own and failed internally with a segmentation fault or something like that, but I'm not seeing an event on it. Okay, cron is running. What is it, systat? Or I'm sorry. We don't know what other services have been impacted. I don't want to take a reboot yet. You follow me okay? Still there?
Yep.
So I was just going through and looked at what CPUs look healthy, except we started to see some action there with metadata activity. But then when I got into memory, I started seeing a lot of memory being used. I started seeing swap 100% full. Then when I was looking at swap, I was trying to do the SAR-W option and didn't have a SAR file for today. Went back and identified that it looked like about 8 o'clock last night that I seemed to have lost several services. Syslog, cron, all those sort of things seemed to have stopped about 8:41 last night, something like that. And then with var log messages and everything else, I could tell that there was an event that occurred. And we do have, let's do something else here, var log SA. So that was the 11th here, SAR-F on SA11. And I can see that SAR crashed at 7:41 last night. Notice there was some CPU utilization going on here ahead of time, but that was ending there. A little bit of IO wait that started in here somewhere. Looks like it started about 20:30. But nothing real relevant there. But when I look at the -R, okay, even here it's not looking bad at that time. But if it crashed, if the event occurred between these two, and it occurred at 21:41, we don't have a final delta record. We don't have one at 21:42 that would show me that event. So I'm not seeing anything there. You okay with what I'm saying? Let me check swap. And swap was full the whole time. Let's see if we can catch when swap got full. Swap started at about 6:20 last night. Again, I just fired up PBS overnight and stacked up the Q. In fact, I want to do something here. Q stat-A. Oops, PBS crashed too. So that was a severe event, and I do have an outstanding PV that there are events that aren't showing up in D-message or bar log messages. There are things that are lost. But again, I could have had a segmentation faults occurring. That's one other symptom of an out-of-memory killer or a out-of-memory situation. You try to address addresses that don't exist, and then you get a segmentation fault instead of an kill. Either could happen. Let me do a man on Malik. Malik is the call to get memory. And there's an interesting comment in here under bugs. This is my over-committing virtual swap concept. We have an optimistic memory strategy. It means that Malik returns non-zero. There's no guarantee that the memory is really available. If it turns out the system is out of memory, the process will get killed by the out-of-memory killer. But it is possible that it tries to address something. I see it more with Fortran than C, where it tries to address something and then gets a segmentation fault rather than Let's move on here. *S, 1-5. I don't know of any way to identify what's out on the swap device. So memory doesn't look too good right now. I'm going to go on, *D, 1-5, look at my disks. Oops, let me try to get a little bit wider. And I do like to do a *DP and then grep for average just to get to the end of it. Oops, I don't have any data there, 1-5. If I have an event going on, I usually try to do like 1-120, try to catch 2 minutes of it. So I do have something going on SDA and SDB. Both drives, by the way, right now are 100% busy, and that's not good. Again, my root device, I want less than 30. SDB, if I'm writing a video stream to it, if its purpose is to do writes of some sort of incoming data stream, then it would make sense to have it busy. And look at SDA has a lot of writes going on, write sectors per second. And, oh, this is not good either. The average wait time in milliseconds, that's close to a second in an average wait time for an I.O. operation. Now, again, I can profile those more closely with block trace and look at each individual IOP and see how long the individual IOPs. Some people don't like to see numbers like that. My opinion is that I don't care if it really is an eighth of a second wait. You know, if this is a case where I don't care if the books don't balance, I'm just going to say that number's big, and I'm going to want to be concerned about it. So sometimes I see that in like a 30-second wait time, and that's just a red herring, a red flag to go off, and I'm not going to bother myself with whether it's, you know, literal or not, because it's an average of all the IOPs. However, in disks, I do see wrapping and corruption of disk activity data with SAR. Even that USPS has some examples where by volume group and stuff, the numbers are so big they're wrapping in the binary format. My service times are okay, but I want these two, the service plus wait, to be less than 60. That's my rule of thumb. If it's over 60, then I want to know what's going on. So I have memory and I.O. problems on this system. My interactive response doesn't seem to be too bad, though. I can do things. So, you know, it's tolerable. I have interactive responsiveness here. But that doesn't mean something else isn't hitting the bottleneck on the resources that are of concern. Oops, I'm trying to write it. I'm having difficulty trying to write. and VI is going through the page cache. Now, can I get, okay, let's do a PS-EL, oops. It's stuck on a log wait. Let me see if I can get this even more. And remember, we had a metadata, that XFS AIL thing going on there. Let me do a PS-P on 31247. Oops. Too late now. I was going to do -O CMD, comma, WChan, but it's gone now. I wanted to see the full path. All I see here was log_wait. And I wanted to get the whole character out of it. If I were to go into, I'm just going to, in my current shell, $, there's a WChan directory there, cat WChan, and that one is on a do wait, which is a normal wait for a parent-child situation. So I was just trying to show you can have different types of bottlenecks. Any questions right now? So let me just see what's going on here. Top disk as a GUI. Again, keep in mind workloads change as you're looking at them, and you kind of want to go back and see, am I still in the same scenario? And I do see SDA having a lot of write activity. In fact, I can see a partition SDA2. Okay, so I got writes going to SDA2. Let's quit out of here, df-h, and SDA2 is my / device. Still with me? So, I got I/O going on, I got memory going on. *R 1 / 5. I'm not done. CPUs looked healthy, memory looked healthy, swap did not. I/O did not. It looks like I am in an I/O situation here more than anything. And after that, it's file system buffer cache. So I want to do a cat of /croc/meminfo. I wish that SAR and TOP would break these things out in better detail. So, 264 gig of memory, 139 is free, about half of it, which is what we were seeing. I got less than a gig of raw I/O. This was the one of concern here. Let's see. There is 122 gig in the cache field. And again, half my memory almost, it appears to be cached. And the question now is that productive or non-productive? I could do a BC free, throw it all out, and see what gets read back in. But that's not the best way to do it, because now you got to read things back in. Now, if I look at this, this is also interesting. Most of my memory use is inactive. It has not been used recently. So 112 gig of my memory is inactive. That tells me it's probably non-productive. It's not being reused. And in fact, I can see most of it was inactive Anon pages application space.
Hey, Dave.
Yeah.
When does it become defined inactive?
Okay, there's a field parameter called swappiness. Now, in Irish days, we had a time window to say move it to inactive based upon a time window. But now it's the swappiness field that determines how aggressively we make it inactive and whether we favor the file or the anon. I don't have time in detail to talk about that right now, but the swappiness field affects how quickly it becomes inactive. If we are a high swappiness, then the anon is going to be inactive quicker. In other words, inactive anons are going to get swapped. If it is a low swappiness, then we're going to have a high inactive file, which means I am more aggressive on my trims. So with the swappiness parameter, I can say protect the page cache because my assets are more important there, such as I'm on a web browser, I got 15 windows I haven't opened in days, and the assets that they had could go inactive. Okay. So a high swappiness will favor inactive anon, and a low swappiness will favor inactive file. And when I do a memory trim, I take care of the slab first, then I go to the inactive anon, then the inactive file, then the inactive anon, then the active file, then the active anon, and then
Yeah, my question had more to do with how long can data be?
You can't give a time window. It's not a,
okay.
In the old days, we could say after 30 seconds or something. So there's not, swappiness controls how aggressively we make things inactive, but there's no time window configuration for that.
Okay.
But inactive data, most of my memory, 112 gig, is inactive and not being used, and it's all anon. I don't care about unevictable. Swap total, again, it's all its swap is full. Dirty. Now, again, I'm only looking at 1 second here, but dirty doesn't look too bad. Half a gig of dirty data. Again, we were seeing writes going off to the root device and the write back. Now, I do wish that SAR would break these things out. I wish that SAR had an option to print these in a better fashion. So dirty, not bad. That's data being written by the apps, copied from user space to kernel page cache. Write back it's in the page cache, but now been marked to flush. Anon pages is my process space. Now, this is interesting to me. Inactive anon is huge up here, but down here it's not. Mapped, by the way, includes attached shemem. Now, we haven't looked at shemem yet. We're at the file system buffer cache layout. But here we are now starting to see our problem again. Half of my memory is shemem. And it appears that most of that shemem is inactive. Now, I happen to be able to be aware of what's going on here, but 120 of shemem, 112 is inactive. We also have 10 gig out on swap. That 10 gig, that swap is full of inactive shemem. So let's move on. Kernel, almost a gig, not bad. I don't like to see the kernel more than 30 gig. And most of that kernel is reclaimable. So a BC-free -F can trim the slab, or drop cache is equals 2 will trim the slab. And trimming slabs are slow, so you got to be careful about that. Any questions yet? I don't care about any of this other stuff. NFS unstable, I do, that's 0. And all this other stuff is really not useful to us. Ignore that stuff. Now, I wrote a script called memstat that basically converts that into a star type of report. It's a simple 20-liner, maybe 40 lines. So it's doing a star type of thing, but it doesn't have a historical binary format to work with. So it's just live to look at memstat in a scrolling line type of thing. And in here I have computed clean. So total memory 264, free 134, cached is 122. Very little of my cache is clean. Dirty, nothing there. Write back, nothing. Anon, nothing. Map, nothing. Slab, not very big. Buffers, and then we can see here the shemem is showing up. So that's a handy little script to be able to watch this stuff more closely. But what I prefer to do is PM chart. I'm not done yet, but any questions? I'm done looking at meminfo. So what was next? Where would you go?
I thought I'd want to see what's going on with shared memory.
Yes, exactly.
FAN.
So in my analysis, I always list that as a separate resource. CP memory disk. We just looked at the file system buffer cache, and by the way, a slab top -S space C would show me my file system assets. Buffer head is for any sort of I/O buffer chain, including dev shemem. I've got sites with 32 terabyte machines. Half of it is dev shemem, and they have a huge kernel for the buffer header to describe that memory resident file system. So I do see metadata in here, the D entry, the inode cache, XFS inodes, the process table. But most of my stuff is, I've got a journal going on. That's a extended 3 journal. This is my I/O buffer header chain, which is more than likely describing the shemem that we're going to see. And then there's this radix tree node, which is just a tree structure. I'm not going to pay attention to that right now. So, CPU memory disk, file system buffer cache, IPC is next. So I'm going to do an IPC S, interprocessor communication status -AM. Okay, not bad. I do have an unattached shared memory segment, but it's only 32 meg. Not a big deal. Now I can do an IPCRM, assuming that asset, which appears to be from PBS, and remember PBS crashed, I can remove that shared memory segment by either the key or the ID. I'm going to use little m 1179648. Do my IPCS again, and I have removed that unattached shared memory segment. Probably left over from the crash last night. Well, wait a second, though. Yeah, we did not reboot, so it would not have lost it. Any other questions right now? By the way, let me check tail bar log messages. I wonder what other services crashed last night. I'm seeing an event. 8:55. We're in an event again. *R 1-5. Again, I've got PBS keeping this system busy. Okay, I'm not going to dig into that right now, but it looks like code 2 GNU, or code 1 GNU. Tried to allocate pages, could not allocate, got an out-of-memory event. Let's just see a little bit more here. I'm going to bring up top. That memory event might be finished. Again, swap is free, but that doesn't, I've still got 122, what we got there, 135 gig of memory free, so I should not be hitting ohms. I do have a code 2 GNU running, or code 4 running that's going to go up to 2 gig, but that's nothing compared to what we had before. Okay, let's go back here now. Now, the IPCS command is for the shared memory segment calls. Sem attach, sem control, detach, get a shared memory segment. If I take a look at code 9, this is the shemem program that's running occasionally. And one of the things we're doing here is doing a shem get. We're saying if the shared memory segment doesn't exist yet, I'm going to create the shared memory segment and then return out of it an ID for the shared memory segment. And then a little bit further down, it's just going to populate that thing with a random number generator. However, I'm not getting rid of the shared memory segment when I'm done. I'm taking out a kill. This is a memory leak going on here. Now, there is another type of shared memory, though. Oops. following me?
Right.
There's my memory leak. That's also why that buffer header is big. Now, dev shmem is limited to half my memory. IPCS is not, by the way. Shmem, I'll show you the limits on that one here in a minute. Oops, this is taking time. I'm having some slowdown here. Probably due to the I.O. that we had going on. Okay. But one of the things I was trying to say earlier, too many people are narrow, single-minded, and only think CPU. I'm trying to say there are 7 things you want to be looking at. CPU, memory, disk. The memory map itself, which breaks out the slab, the dirty, the write back, the clean. In other words, the file system buffer cache. Then IPC, then your miscellaneous things like peripherals or networks. Oops. Dev shmem is a TempFS file system. And right here, I can put a limit on dev shmem. The default is half my memory. Okay?
Okay.
Also, this is another important one here. With TempFS memory resident file systems, I can determine my allocation policy, whether it's going to be first touch or round robin, and specify even a particular node list that I want this dev shmem to be on. So I can make memory resident file systems and place them in the topology, and then determine how I'm going to allocate within the carved out nodes that I've said are going to be used for this. So, the default, I believe, is first touch, allocate memory from the local node, and that gives me affinity. So if I create this big file, it's going to fill up one node, then the next node, then the next node, then the next node. And then those nodes are basically unusable if the CPU scheduler puts something there. It does not check to see if there's memory available. So in this situation, since the file that I'm talking about here is bigger than a node, I might want to consider an interleave, in particular an interleave across a certain set of nodes.
Mm-hmm.
Okay. Again, my rule of thumb, if it fits, keep it local. If it doesn't fit, spread it around. So let's check something here, cat/proc/mounts. Looking for the dev shmem one up here. No particular memory policy or anything like that. It's going to be first touch. You okay?
Yeah, now if the process writing into dev shmem is in a CPU set, will the memory allocation be limited to that CPU set?
No. This is file system I.O. It will be limited based upon the hard wall, which isn't working, and so there, in that sense, it would be limited to the CPU set.
So if you said interleave, would it interleave within the nodes within the CPU set?
I don't think this one does. No, it has a different memory policy than the spread page cache, what you're talking about, the memory spread page.
Okay.
These are going to be first touch. Let me do something here, node info. And you can see how several of these nodes are basically out of memory. 4, 5, 6 in particular are way out of memory. Now, I have a patch and an RFE to add shmem into this tool. So I can't see the shmem over here. Also, on a per node basis, the cached field is not available. Now, this is coming out of /sys, devices, system, node, and then the node number. I'll just pick node 0 here. And there's a mem info in there. That's where the data is coming from, but there's no cached field in here. But there is a shemem field. So I have my own node info. Let's see if it's in here. N info is what I'm calling it until the patch is in place. Let's see if this works. And looks like some sort of problem. This is a bug. That's a bug. That's the wrong one. Taking a little bit for that RM to work. Again, I know there's some metadata activity going on. See if we can catch it here before it's too late. Oops, too late. Anyway, I want to go back to top, see where we are. So I got those code 2, code 4s, one LS running. Well, I am seeing the flush daemon kick up. I'm not seeing any K-swap Ds, though. There's the journaling activity. There's a flush going on. I'm going to do an F, Y. Actually, let me go F. Get rid of priority. It's useless. Unless you're in a real-time market. Only real-time is priority meaningful. Everything else will have a priority of 20 and does not change. I'm going to get rid of share. I don't like that one. And I'm going to do a Shift W, capital W, to save that off. Oh, I got some code 8's running now. Code 7's running. I'm now, look at the I/O wait time. Let's see if we can catch one of these. 33849. I can see it there. I/O wait time, right there. Seen a lot of CPU wait time as well, but there's your I/O wait. That's data I/O wait, not metadata I/O wait. That's block I/O wait. Bring up top again. There's a log activity wait, so we got a lot of things that are waiting here. Again, a get request, there we got flushes going on. A get request is an I/O wait, gets counted as an I/O wait. Sync page, block congestion. Oh, I just saw K-swap D kicking in. I wonder PS-E, grep for K-swap D. So you can see 3 nodes here that had K-swap D activity. So what's all that from? That dev shemem.
Right.
So I leaked memory, but I also created a lot of side effects from that sort of thing. This won't show up with IPCS. Now, one of the questions I have is that big file actually being used by anybody? So you got access times and things like that. But I'm going to do an LSOF and grep for big file. And it doesn't appear to be opened by anybody. Now, that doesn't mean that some program might have left it there, and a couple hours later, a batch might start up another job that comes in, attaches to it, and use it. But that's not that common in the batch market. Okay, *R, 1 space 5. I'm just going to see where we are. 52% of my memory used. *capital S. Swap all used. Well, let me go to top disk. So I kind of know and pulled apart memory and found that most of the memory was that dev shemem. So SDA2 is still busy, SDB is still busy. So I'm going to do a IO top. Now this was integrated into SLUS 11 SP2. It's been in Red Hat for a little while here. And again, I know that the main problem on the system is IO. Yes, we do have out of memory on some nodes and stuff like that, but we're not feeling the impact of that as much as we're feeling the impact of the busy disk. While that's happening, let me pull up the other one here. Oh, there it is. So looking at the I/O, flush daemons, kjournald, kswapd. Oh, code 8 was running. Postgres for my statistics, kswapd. I wonder if we actually do have some swapping going on or whether those are trims. Don't believe these numbers here. I have seen them unrealistic where they're in terabytes per second and stuff. It's a derived number. But here now I'm able to see my top I/O processes besides the flushing and the metadata activity, kswapd activity. Code 5 and code 8 appear to be the main apps. Okay. Top disk. Oh, wait a second. DF showed SDB, SDA2 busy, but it also showed SDB busy, which is data 1. How do I find out what processes are in a file system? Fuser. Go to data 2, that's the SDB that was busy. I see one process on that thing, LS. Let me do it on slash, and you're going to see everything. So there are a lot of things that are open there, including code 8 I'm seeing in there. Now this doesn't mean they're actually doing I/O into it, it just means that they have things open in it. My kswapds. I want to go back, sar-big W, 1-5. I'm not seeing any swap activity, yet I'm seeing kswapd show up, sar-big W. So everything that's out on swap, there's no swap I/O going on here at all. Okay? So now the next thing I'm going to do here is strace on that ls-p. What was the PID of that ls? We don't have it here anymore. And oops, we got something going on here. We're getting system calls that are returning a no error, no data available error out of these directories here. What did top give me again for system time? Seven and 8 are still running, and we haven't profiled those yet. I just saw LS sleeping on an XFS buffer weight here. Look how much CPU time LS has had, too. So there is a little bit of system time here. There's my kswapd. I wanted to do something else. sar-b 1-5. Oh, there's the kswapd activity. No swapping going on. No, the major page faults are next to nothing. I'm not sure what this one is here. But all here, we're scanning pages, 33%, oh, let's just take this one. Interesting, it's jumping all over the place, but we scanned, in this case, 38,000 pages and 32,000 were trimmed. We have trimming going on here. That's why K-swap-D is busy. Even though there's no swap traffic, K-swap-D is busy managing memory on a couple of those nodes. Again, a PS-E, grep for K-swap-D, and we can see the nodes, 4, 5, and 6. Any questions right now? I want to kind of clean some of this up. So we've kind of got a memory and I/O situation going on. By the way, I better do a df-h and check. My root is only 24% used. That's fine. Dev shemen was 100% full. Let me clean that up in a minute. I want to get PM chart running. Now what else should I check in disks? df-ih. We have another problem here. If I were to try to do a touch/data2/x, no space left on device. df-h shows data2 is only 31% used, but there are no inodes free on that file system. Now I wanted to look at TopSys to pull this apart because we were seeing some system time. We attached to LS with the S trace and saw system calls failing. But looking at the system time here, code 7, the journaling activity, and LS appear to be my system time. And I'm going to try this, a perf top. Again, this can be dangerous. I still have my system. System is still responsive. It's just perf top, ps-el, grep for perf. That's in an I/O situation, a GET request situation. Let's see if we can catch that before it's too late. Crash/boot/vm splat gz. This is going to have the same problem, though. It's got to do I/O to the root disk, and that disk is 100% busy. There we are. So I'm not seeing a whole lot of system time here. Most of the system is idle, so we're seeing that. I don't have a particular PID that I can attach to at this point. I should have attached to a particular PID. But this raw spin lock, hierarchy save, more than likely there's a raw spin lock as well in there. And raw spin lock, tri-lock. Let me quit out of there. ps-e, I want to grep for code. Let's do a perf top-p on 34593. Oops. I used to be able to do that. What's going on here? Dash PID. Huh. Maybe it's a wrong PID or something. Got a problem with the PID or something, but Looks like that PID is gone. I'm not getting any. There we are. So now I've attached to another code 8 that was running, and I can see the majority of that system time is due to this journaling activity. Again, this is on a root extended 3-file system that that thing was writing to. LSOF, rep for code 8. And it is writing into a PBS directory here. Right here is the file. So our batch jobs for PBS are writing into a scratch temp PBS directory. And that's the majority of that root activity. And the other data, too, was an ls command. I want to wrap up here in a few minutes. Any questions right now?
Nope.
So, for me, I want to clean up some of this stuff. Let me bring up Performance Copilot first. So that Deb Shaman Big File X is a problem with an unattached segment to it, nothing attached to it, and I want to clean that up. And you might want to bring up a slab top dash S space C and watch the buffer head change. Oops. So I'm just going to build a series of charts here. Oops. So there's my CPU one. I'm going to create a new tab here. We'll call this one All. Open View. Get my CPU on first. We did this yesterday. I just didn't save it on this system. I only saved it. I could have moved it from Floyd to this system. Open View. Swap. Now, if you remember what I mentioned yesterday, free is on the bottom and used is on the top. And I'd gone in and flipped them around because I kind of like to see swap on top of memory, and when memory gets full, I like to see swap fill up from the bottom up. That's just personal preference. This time I'm going to do my own chart for memory. As soon as I clean this up, we're going to take a break. Utilization. Again, this is all personal preference on how I do it. I kind of like to do slab first. So if you've got a large kernel, that can be a problem because it won't start at 0. The chart won't start at 0. So I'm going to do slab first. Sometimes I'll just choose something like page tables to get something real small that won't change too much. And then I want to do my raw I/O. And then I'm going to do my dirty. And then dirty's data that's been written, once it gets marked to flush, then it's going to go to write back. And then if it's writing to an NFS server, it goes to NFS unstable. That was not available in SLUS 11. That came out in SLUS 11 SP2, I believe. And then after that, cache clean. So basically, if I write to an NFS server, it's going to go dirty, then write back, then NFS unstable, then clean. Okay, after that, personal preference, I'm going to put my process space on pages on top of that. Then I'm going to put mapped. Now, mapped is primarily attached shared memory segments. see. Then I'm going to put my free. Okay, let's change the colors. Let's fix this now. I'm going to put in a title here. I'll change it to a stack bar. Again, I'm trying to equate what GrossView did on IRIX. And plot colors. I want to change free to be green, just personal preference. I want to change the non-pages to be blue. I want a lighter blue. What happened here? The free. Mapped. I'll go black. And again, no personal preference, but I'd like to see dirty to be red as a warning type of thing. You generally should not see writebacks, so the color's going to be real small. NFS and writebacks can be bad in an NFS environment, though. Cache clean is brown is okay, and again, I just like apps to be blue, and what's available in memory to be free is green. And we can see half of my memory is cache-free. Again, I can go in here, click on something, and it'll be taken out of the chart. So let's see what we got here for get free out of the way. Buffman, about a gig. Let me get that out of the way. The slab. There's my dirty, about 25 meg. Let me get rid of that. And we got 0 writebacks. Looks like our IO is done right now, so we're not going to see writebacks. Let me move on, though. So I'm going to open view, and this time I want to get disk. These are IO operations per second, total for all drives. And I want to do file system, showing me how much disk space is going on there. Now, if you notice, these things are getting too small, but at least I can get a full picture of everything here. So let me save that view. Just call it all. Okay. Now I'm going to create another tab. Let's call this just memory. I'll go to that one. I'm just going to save time here, and I'm going to open the prior view and then just delete the charts. I'm just going to open this all. Again, if I click, notice there's a blue here. If I click in something, I'm going to click here, and then I can close the chart. This one's going to be just memory. Now, right now, I want to keep these two on the same page, and I'm going to add one more here. Again, that has problems because you run out of space for everything. I want to add in Shemem. Add in, let me save that view. Add in one more. As soon as I clean this up, we're going to take a break. Now for VM stats, let me get into PuTTY here. I want to see the trims and stuff. So let me just cat/proc/VMstat. This is where I was looking at the wrong statistic the other day. Looks like it is the normals that I'm interested in. So this is what we were looking with SAR-B. This is K-swap-D in the kernel doing page scans and page steals. So I want to look at all the normal ones there. And then also inode steals, these K-swap steals here. I want to create one. By the way, I have a tool to look at this called VMstat. Wasn't wide enough here. Quit out of there. Looks like I still got a problem with the wrap. But what I was trying to do is figure out, this is a delta type of thing, just giving me the individual statistics. And it's obsolete. Again, I was looking at DMAs in this day, not the, everything seems to have changed with this new SP2 kernel. So that's not going to help me. Get rid of that. So I'm just going to have to pull this together myself. New chart, VMstat. Oops. I might have others where I'm going to do allocation stalls, but I'm going to leave that alone right now. Let me do the inode, K-swap inode steals, K-swap-D steals, and any other steals in here. Inode steal. Page rotation is what you were asking about. That's what makes a page inactive. I'm not going to plot that right now. And then page steal normal. That's the one we were interested in. Okay. Looks good for that. Apply. I'm going to do a second one now. I'm not going to stack those, by the way. VMstat. This time I want to do the scans. Activation and deactivation. Deactivation is another page rotation thing. So here we are with our scans. I want the normal. And I think that looks, got the steals, got the K-swap-D page scans. Okay. That's pretty much the K-swap-D type of activity. I'm not interested in allocation, deallocation, activation, deactivation, or anything right now. Well, we did have a little inode steal that happened there, 14,000 inodes stolen. Remember, LS is running, and we have a slab that's trying to grow here. Any questions right now? I'm going to go to here and change my sample interval to get more data visible here. Are you still there, Gus?
Yep.
Wanted slab top running. You still there, Gus?
Yeah, I'm here.
So get a slab top up and running. I'm going to remove that file. Oops. Come on. And again, we have a couple of different things going on here, but most of this appears still to be metadata situation with that LS going on and the slab going on. R-R1-4. Let's just see here. So we're at 47% of my memory free. So let me, first of all, before I start this slab, top dash S space C, I always sort by cache size. So we've got that radix tree, the buffer head, and then we got metadata. Again, these size fields, that would be any routine that needs a 1 KB structure. This is for preventing fragmentation and avoiding having to do garbage collection coalescing of the slab, the kernel heap. By the way, I was at a site with GPFS running, and they had all the page cache. They didn't use Linux page cache, but the GPFS daemons were doing 16 KB buffers in the slab for all their I/O, putting it in the slab instead of the Linux page cache. Okay, so let's just see what happens here now. Big file. Remove it here. We'll go to memory here. And you can see right here, the Shemem is going down rather quickly. How about your slab top? Looks like it's finished. And by the way, our swap cleared up here as well now. Did the slab go down during that? Let's see.
Journal head still shows 98%.
Huh? I'm not sure what your for percentage. I don't know what we'll take here in a second. Now remember, the slab's got LS going on too. But I was interested in the buffer head. Percentages are meaningless. Don't use those. The only thing you care about. But you're right. There's still a buffer head. And radix tree did go down in the list a little bit. And buffer head now is at the top of the list. Let's do a more on /proc. Info. So most of my memory is free now. I do still have those buffers. So that buffer head that we're looking at might be the journaling activity. Extended 3 journals are in the buffers, and they are not fixed in size like XFS. I'm going to try to create it later this week and create half my memory being buffers and all of it being the journal. Cache is real small now, less than a gig. We do still have a little bit out on swap. Again, the inactive is gone now. The inactive anon is gone. We still have mostly active file. Swap is pretty much free. Dirty is rather large right now, 400 meg. A little bit of write back, a little bit of anon pages, a little bit of map, and very, very little Shemem. And our slab is now at 870 there. Let's see if it's growing still. So it looks like the slab is growing. Can we see it over here? Get rid of dirty. Get rid of buff mem. And let's get rid of the application space. So this is just showing here are the trims that are going on. Let's see if we can catch those trims. So here are the steels going on. It's going to roll off here real quickly, and some of them should correlate to these. I wasn't able to really catch them quick enough. Got two there. Looks like you can see a trim there and a trim that happened in what about this one though? Easier if they're all on the same. There was a scan there, but I don't see a whole lot of trims going on. Let's go to top. So we do still have other things going on, but I just basically cleaned up that shared memory segment. We still do have journaling activity. The journal is still hot. A little bit of IA wait time still going on. I just saw a log wait going on, so we still have metadata journaling activity going on, some of that from LS. System time, bouncing up and down. Remember, we still have a DF-I problem for data 2. Let's bring up top disk. And SDA is being written, but SDB is just being read. That's the LS that's going on. What I was wondering about was journaling there. No, a little bit of journal activity. We got some writes going on to SDB right now. If I had top up, we might have been able to see the journal run, trying to correlate the different things. So that activity we were just seeing is this here. That's all. Basically, LS is modifying the access times of the inodes of the files, resulting in a metadata change, but no space change. IPCS-AM, nothing there. I'm ready for a break.
Okay.
Stopping the recording.